Back, Stat7 6, there is only one problem here. And the question is, a baseball player has a lifetime batting average of 0.248. That tells me the probability of success, little p, is 0.248. If in a season this player has 280 at bats, what does that mean? He gets to try bats 280 times. What is the probability he will get 65 or more hits? Question is, what is the probability that R is greater equal? So you see, 65 or more is 65 or greater than 65, equal 65 or greater. So that's what it means to be greater equals 65. All right. So we need to make some correction for continuity. That is, this is in R. We need to make it for X. All right. And that X is either 0.5 to the right or 0.5 to the left. If you remember, if you draw a picture here, okay, this is how we explained in the class. Look, somewhere here is 65. To the right of 65 is 66. To the left of 65 is 64. And the rectangle above 65 goes from between 64 and 65 to 65 and 66. What does that mean? The sides of the rectangle start at the midpoint between 64 and 65. So that's 64.5. And the other side goes to the other midpoint. So that's 65.5. All right. So that's going to be the rectangle over 65 in the binomial distribution. So I want to go 65 onwards to the right. Okay. When I do this, I'm dragging the entire rectangle to the right. In other words, I'm dragging this point on to the right for my X. So that point is 64.5. All right. So now, before even we do all this, we need to check one thing and two things, that is, n times p is what? N times q is what? All right. P is 0.248. So Q is 1 minus P, which is 1 minus 0.248. So let's bring in our calculator. There you go. So 1 minus 0.248 is 0.752. Okay. So, all right. So what is n times p? N is 280. I'm going to multiply it to p, 0.248. Let's see what that is. 280 times 0.248. That gets me 69.44, which is a good number. What is a good number? I want to be greater than 5. That's all. Now check again with Q. 280 times 0.7552. All right. So 0.752. That's 210, which is even better. It's better because it's greater than 5. So we can use the approximate normal distribution X, all right, with mean. What is with mean? What is the mean formula? Mean is, in this case, mu. For binomial distribution, mean will be n times p. N times p we just calculated, it is 69.44. And standard deviation is sigma, that is square root npq, that is equal to, let me write it here, square root 280 is n, p is 0.248, q is 0.752. Okay, so we are going to use those numbers. Square root 280 times 0.248 times 0.752. So that is your standard deviation. All right. So you have come this far. Now all we need to do is find this probability by standardizing it. Okay. So we want to standardize it. We always standardize it using the fraction. The standard formula is x minus mu over sigma. In our case, the fraction x minus mu is 69.44 and standard deviation is what we just calculated. So I want x to be greater equals 64.5. Okay, that's the probability we are looking for. So why don't we use this standardizing approach, one for x and the other for 64.5. All right. So once you have come this far, this expression is standardized score z greater equals this expression we better calculate using our calculator. Okay, so you have something over 7.22626311. Numerator is 64.5 minus 69.44. So that is the right hand value. All right. Now is the time to approximate. So 2 digits, 6, 8, and after 8 is a 3. So I don't need to do anything more. Z greater equals negative 0.68. Okay, so this is equal probability Z greater equals negative 0.68. So notice what is greater equals, that is the right hand area. You obtain right hand area by taking 1 minus left hand area. That is 1 minus the left hand area for negative 0.68, negative 0.6, and then you have 8 somewhere here, right? So negative 168 gives me here 0.2483, 0.2483. So 2483. So that's your final answer. Okay, 1 minus 0.2483. Submit. Good. That completes this particular section. Next videos will cover chapter 8. Until then, bye.